All right, so we're going to look at domain and range and specifically how to put these things into interval notation, which is new for you. So domain you've seen before, range you've seen before. The set of x values is your domain, or it's also called the independent variable. The range is your y values or your dependent variable. So we're going to look at those, and like I said, we're going to sort of formalize the notation that we use. So domain and range, the first one here is given to you in terms of just a set of points. It's 4 distinct points that we're looking at. So my domain for this one would be my x values, and the set of x values, you can write them in ascending order. So -3 is the smallest value, and then -1, and then 5 and 6. Or you can put them in the order that you see them. It really doesn't matter. And then the range are the set of y values. So looking at all the y coordinates, again, I'm going to do this in ascending order. So -1 comes first, and then 1, and then 2, and 4. So those set of values are my range values. So looking at distinct points, if any of these x coordinates repeat, so if I have any that appear more than once, my graph would not be a function. And since this one, they don't repeat, then it would be a function. And so this particular example that I gave you here is a function. And it's kind of old stuff that we've seen before. You may not be given the equation, or you may not be given the problems in terms of a bunch of a set of points. You may be given an equation like this. Bonus example, this is not in your notes. So you can add this one in here if you like. Sort of builds up to some of the harder problems. So for this one, I'm going to go through and look at the graph. So if I'm looking at this, my x-intercept is going to be at +1 and -5. We know this thing is a parabola. If you FOIL that out, you'll have x squared, what, plus 4x minus 5 would be the graph of a parabola. So my x-intercept is at +1, and my x-intercept is at -5. Right? And it's a parabola that opens upward. I can find the vertex if I want the vertex. Halfway between -5 and 1 is going to be -2. If I plug -2 back into this equation here, I'm going to have a y coordinate of -9. So I can plot that point if I like. I'm going to be off the graph here. So that vertex is at -2, -9. So now when I look at the domain and the range for this one, my domain is still my set of x values, but it's not going to be a distinct set of points this time. Now I got to sort of set this up as an interval. There's a whole bunch, an infinite number of points that would fit the domain for this. So my domain is how far to the left is the graph going to go? How far to the right is this thing going to go? Or are there any values that I can't put into the equation for x? And in this case, there isn't. So it's all real values. Okay, or maybe you use this notation, the double R, sort of the double bar with the R there is another notation. So those are old notations. A more formalized notation would be to say specifically, my graph goes from -infinity to infinity, all the way to the left, all the way to the right, any values I want for x. But I need to say that this is an interval. And to say it's an interval, I'm going to put parentheses around this. Parentheses means it never actually touches that value. Infinity is a concept. It keeps going on forever. So it's never actually going to get there. So that's why we have parentheses for that one. And then our range is my set of y values. So how far down does the graph go? So bottom to top is what we're looking at for range. So how far down to how far up? Well, how far up, it's going to infinity. So that's kind of the same as what we did back here. But how far down it goes is -2, and it actually touches that point -2. So it goes from -2 to infinity. Well, infinity we said would be a parentheses for the notation because it never actually reaches infinity. But my graph does touch -2, so I can't put a parentheses on this other side here because it actually does touch -2. So we need something different to notate that it actually equals -2. So instead of parentheses, we're going to use a bracket. So it's the same idea as saying y is greater than or equal to -2. These two notations mean the same thing. The one was the inequality notation that you used before. This one is called interval notation. All right, let's look at another basic equation first, and we'll get into one that's a little more complicated. So the second bonus example here, x squared minus 4, I'm going to graph it. You can graph it in your calculator. And it's something like that. This vertex is down here at 0, -4. Yep, looks good, 0, -4. So if we're looking at domain again, it's a parabola. I can put any value I want in for x. So my domain is all real numbers, -infinity to +infinity. And then the range, how far down and how far up does the graph go? Well, it goes all the way down to -4, and it goes up to +infinity. It never touches infinity, so it's a parentheses. It actually equals -4, so I need a bracket on there. All right, so they're kind of basic examples there. The next one's more complicated. It's still a parabola, but I got to figure out it's not in that factored form, and it's not. It's actually shifted off the axes. So let's pull up the graph. Let's graph this one in the calculator. Look at that. So let's graph this in the calculator. We got y equals -3x squared plus 2x minus 1. If you graph that parabola, it looks like that. It opens downward. It would be nice to know what that vertex is there. So to find that vertex, I can hit my second button and the trace button, which is the calculate menu. And if you look at that point, it was the high point on the graph. It was a maximum. So we're going to find the maximum. And it says, what's the left bound? So you want your cursor, you can see it flash in there, somewhere to the left of that high point. So anywhere here is fine. I can hit enter. And then now it's asking for the right bound. So now I need to use the arrows to move this cursor over to the right side of that high point. Hit enter. You don't want to guess because that's why you bought the calculator. Hit enter one more time, and it gives you the coordinates for that vertex there. So the vertex for this one is that, and I flipped it down here, I can't see what it is. One second, we'll back up. There it is. So it's at 0.333 that repeats, and -0.666 that repeats. So that's 1/3 and -2/3 if I change those repeating decimals into fractions. So that's my vertex for this example B. So let's go through and plot that point then. So let's make that 1 there. So 1/3 would be here, and then we'll make this -1 and -2/3. So there's my vertex. The parabola opened downward. So that's kind of the graph I'm looking at here. The vertex was 1/3, -2/3. So for this one, then my domain, I can put any value I want in for x. So again, it's all real numbers. And my range, the lowest value, so I got to work bottom to top for this one. So the bottom number would be -infinity. The tails keep going on forever. And the highest value goes up to this point right here, and this point is at -2/3. And it actually equals that point. That's my vertex. I need a bracket on the end of that one. All right, so that one's a little more complicated. You use your calculators for these because some of the equations are much more complicated than just maybe a nice parabola. All right, let's look at the next one here. This one is in your examples as well. So you got 1/x² minus 9. So 1/x² minus 9, much more complicated equation. You've got all kinds of asymptotes in this one. When this denominator is equal to 0, you get x is plus or minus 3. So if a denominator is 0, it can't actually equal that value. So they're going to look like vertical asymptotes. The graph gets close, but it doesn't actually reach that point. Vertical asymptotes, I use VA for that. And then if you graph this with your calculator, you're going to see some other things happen too. So let's pull this one up within the calculator. So I have 1 divided by x x squared minus 9. Okay, graph. So I typed something in wrong here. Let's see. Oh, I missed my 1. 1 divided by x squared minus 9. Let's clear all this junk out. All right, now I think I'm good. All right, so let's hit graph. All right, now that doesn't look very clear. I think we're looking at too much of it. Let's kind of zoom in some. Let's hit the window button. And instead of going from -10 to +10, let's go -6 to 6 for my x. And we'll do the same thing for y. We'll see how that looks. Just zooming in a little bit closer so I don't have such a big window. All right, that looks a little bit better. Now it kind of cuts off a little bit. The calculator doesn't sort of continue this graph here, depending on what kind you're using. These tails continue on, up in this direction and out in that direction. This tail continues down here and down here, up in that direction and on. So you can kind of see in between here, this is -3, this is +3. That's those asymptotes that I was talking about. So let's put those, we got them in our graph there. You also have another piece of the graph here. The tails are approaching the x-axis here. So let me just kind of sketch this here so you can see what's going on. So it's doing this. This tail is doing this. And then in between here, it kind of looks like a parabola that opened down here. Okay, so that's the graph that we're looking at. So if we're looking for domain, this part changes a little bit. The domain for this, starting from left to right, from left it goes to -infinity. And then it's coming in and I have a problem here at -3. At -3, the graph jumps from this top point down to this bottom point. So at -3, I have some kind of change going on there. It never equals -3, so I need parentheses. And then my graph continues on. It continues from -3 to +3. So it continues from -3 to +3, again, not reaching those 2 points. And then the graph continues again from 3 to infinity. Now I want to say and. It does all of these things together. Okay. In interval notation, you use a U. The U means union. It means all together. Okay, so U is just another way of saying and. So all 3 of those things are happening there for your domain. My range, the graph comes up to the y-axis. It never actually equals 0. If you try to solve this equation, if you try to set it equal to 0, there's no value for x that's going to make this thing 0. So this can't happen. So it never actually touches 0. And we'll talk about horizontal asymptotes later on. So my range for this one goes from bottom to top, lowest value is -infinity, up to 0 but doesn't equal 0, and then it continues from 0 up to +infinity. So this is a fancy way of saying y doesn't equal 0. This is a fancy way of saying x doesn't equal +3 or -3. Okay, so it's just interval notation. You just sort of work from left to right for domain, bottom to top for range. For part D, you can again look at this graph. If you graph this with your calculator, let's see, here's 1, here's 2. This one starts at 1 1/2 or 3/2 and continues on there. So that point right there, I want to call it a vertex. It's really not a vertex, but it starts at 3/2, 0. That's the coordinates of that point. So if I look at this then, domain, as far left as the graph goes, it starts at that point at 3/2. And it equals 3/2, so it'll be a bracket. And then going to the right, the graph continues on to infinity. And then range goes from bottom to top. So the lowest this point reaches is 0. And it actually equals 0. That's the coordinates for that first point there. And then the graph continues up to infinity. So these last ones are much more complicated examples. Not all the problems will be that complicated there. All right, so domain and range using that interval notation. The next thing you have is intervals for increasing and decreasing. And it's basically just describing what happens to the graph from left to right. So the first thing you might want to do is fill in these points. The coordinates for these points are these maxes and mins. Now they didn't give me an equation for this. We're just trying to estimate this here. So that's -1. This is up at 3. And this point here looks like it's at 1, -1. So if you look at the graph going from left to right, from here to here, the graph is increasing. So from left to right, it's increasing from negative infinity until I get to this x-coordinate of -1. Then let's decide what the graph is doing. So from -1 to 1, the graph is decreasing. And again, this is an interval, not a point. And then if we look at the graph, the next piece of it from 1, then it continues going up, so it is increasing. So n is a U symbol. From 1 to infinity, the graph continues to increase. Intervals for increasing and decreasing are always the x values. Okay, the y values determine whether it's increasing or decreasing. So if you look at some of these points, this point is at what, like -2, -2. Another point here. What that one? That one looks like it's, I don't know, maybe -1.90. And then let's pick this point here. It looks like maybe -1.5, 2. If you look, the x values are what's in the interval. It's the y values that tell you that it's increasing. We went from -2 to 0 to 2 to 3. So that's how I knew it was part of the increasing branch and not the decreasing. So the y values tell you whether it's increasing or decreasing. The x values are what go in the intervals there. Let's get one more of these. Oh, relative max and mins. You did this in Algebra 2. You can do this with your graphing calculator. Okay. So you can put this in your calculator, x cubed. Try again. X cubed. One more time. Cubed. There we go. Minus 4x minus 1. All right, let's hit zoom, and 6 will reset that window to go from -10 to +10. If you want it reset again, you don't have to reset it. So it says find the relative maxes and relative mins. So I want this maximum point and this minimum point. We kind of did that with the parabola in the beginning. All the good stuff is in second and calculate, which is the trace button. We'll find that first one, which was a maximum. It asks for the left bound, so move your cursor so it's to the left of that first blue point, anywhere on the left. Try to do it again, I messed up. There we go. Maximum to the left, we'll hit enter. Move it to the right. Hit enter. You don't want to guess. Hit enter again. So we've got the coordinates for that point is 1.154699. We're going to round this to 3 decimal places. Round everything to 3 decimals. Okay, not sig figs. So let me pull this up. It disappears when I grab a pen. So -1.55 is my x coordinate. .155. One more time. -1.155. There we go. And my y coordinate from that was 2.079. This point down here. If I go back to the calculator, I can do the same thing again. Scroll over to the second point and work with that second point there using the same thing, but I need to go in the second trace, and now this time it's a minimum. So my left bound, my right bound, got the minimum value. So this minimum then is at negative 1.155, and it's, I'm sorry, positive 1.555, and it's negative 4.079. So minimum, maximum. This term relative means that it's not the highest point or the lowest point on the curve, because the curve continues on to negative infinity and positive infinity. It's just telling you specific changing points in the graph there.